today we're going to be talking a little bit about the distance formula. Now, for the distance formula, what I mean by that is we're going to look at how to compute distance in an XY coordinate plane. So, for example, if I had a coordinate plane here, an XY plane that was ticked off this way, kind of ticked off, is it a man? It's an angry coordinate plane. But anyway, so here it has tick marks, 1 through 5. And suppose we had a point here at 2, 1, so that's the coordinate here, and another point here at 5, 5. How would we compute the length of the line segment between these 2 points? That's what we're going to look at today. Now, in order to get to that, we have to review a little bit about the Pythagorean theorem. So the Pythagorean theorem takes a look at a right triangle that has side lengths, leg lengths, A and B. So these sides here that are not opposite the 90-degree angle are called legs. The side opposite the 90-degree angle is called the hypotenuse. We typically label the legs A and B and the hypotenuse C, and that produces the Pythagorean theorem, A squared plus B squared equals C squared. You can actually see the Pythagorean theorem work in this graphic here, where you can see we have 4 different triangles that are all identical, all with side lengths A, B, and hypotenuse C. And when we arrange them like this on the left, you can see that the 2 spaces that aren't triangles have to be squares of side length A and B. So the area that's not covered by a triangle is an A squared plus a B squared. But if we rearrange the triangles into this configuration here on the right, you can now see that the same 4 triangles are there, right triangles with legs A and B and hypotenuse C in the same overall square. So we just rearrange them. Now the space that isn't formed by triangles is actually a square of side length C. And so that same amount of area that's on the left, which is A squared plus B squared, has to equal the amount of area that's missing on the right, which is C squared. This is a simple geometric proof that should convince you that the Pythagorean theorem works. Now, we're going to use this idea here in order to figure out how to compute the distance in our coordinate example. So if we come back to our XY plane example here, what we need to do in order to find this distance here is we're going to try to create a triangle where this is the hypotenuse. To do that, what we'll do is we'll look at the horizontal line that goes through the base point, the bottom point here, and the vertical line that goes through the other point. Since this line is vertical and this line is horizontal, we know that the angle that they form when they touch each other is a 90-degree angle. So we end up with a right triangle here, and we can figure out what the lengths of each of these sides are. So in this case here, this length here is the horizontal distance between these 2 points, which is just looking at the x-coordinates. This x-coordinate is at 5, this x-coordinate is at 2. So in order to get the distance there, we could just count, going from 2, 1, 2, 3, or we can actually just take the difference, 5 minus 2. Either way, this side length will be 3. Up here, we do the same kind of thing, but now we're going to look at the difference between the y coordinates. Here we could start at 1, which is the y coordinate here, and go 1, 2, 3, 4 to get the difference, or you could take just the subtraction, 5 minus 1, and get 4. But nonetheless, that side length here is going to be 4. Now I'm going to point that out again because it's going to become important. This one came from 5 minus 2, which is the difference in the x's. This guy right here came from the 5 minus 1. So this is equal to 3. This is equal to 4. So since we know that these are the lengths of the 2 legs, we can take the distance here, which we'll call c because that's what we did with the hypotenuse. Or if you want, we could call it d for distance. So let's do that. Call it d for distance. But it's the hypotenuse's length. It's the side opposite the 90-degree angle. So from the Pythagorean theorem, which states that a squared plus b squared equals c squared, we just need to plug all these things in here. Well, the 3 and the 4 are the 2 legs, so we get 3 squared plus 4 squared, and the c is this d over here. That's the d squared thing. We don't know what that number is. That's actually what we're trying to find. We're trying to solve for this d here. So if we simplify this, we get 9 plus 16 is equal to d squared, or 25 is equal to d squared, which tells us if we square root both sides, that d has to be equal to 5. That last step there was square root of 25 equals the square root of d squared. Technically, when you square root, you have to look at both a positive and a negative possibility, but since we're looking at a distance, we don't need to worry about the negative possibility. So this tells us that this distance here should be 5. Great, so that's how we handle this example. But let's take a look at how to do this in a more general setting. All right, so now let's take a look at how to do this in general so we can actually get to a formula. So now we have an XY plane here. At this point, it doesn't matter how it's ticked, how the tick marks go. We'll just start with 2 arbitrary points, and we want to find the distance between them. Now, because we want to do this for every possible point, we don't want to tell you what the actual coordinates are, because they really should be able to stand in for any point you pick. So we have to use variables in order to talk about them this way. So in the first coordinate, instead of giving you 2 numbers, I'll give you 2 variable names instead. Up here, we'll call this coordinate x2, y2. And now what we need to do is form that same right triangle by looking vertically along the second coordinate here, the second point, and horizontally along the first to get a right triangle. We now have to identify this length here and this length here. To do that, as before, we did this one by taking the difference in the y values. So this is going to be y2 minus y1. Now, technically, the points could be anywhere, so it is possible for these to be sort of switched like this. So really, I should think of this as the absolute value of y2 minus y1. But it turns out that in the formula, I don't actually have to remember this because it's going to be handled by something else. And we'll see that in a second. Over here, to get this distance, we want to again look at the difference between the x values instead of the difference between the y's. So this would be x2 minus x1. But again, because we're looking at some kind of distance there, we want to make sure that it's positive. So it doesn't matter which way you have them oriented. So we'll take an absolute value. And we'll call this distance that we're trying to find, we'll still call that b. Well, according to the Pythagorean theorem, c squared has to equal a squared plus b squared, where a and b are the lengths of the 2 legs, and c is the length of the hypotenuse. So this produces a d squared, because that's what the length of the hypotenuse is. The a is going to be this guy, and the b is going to be that guy. So this will give us absolute value of x2 minus x1 squared, plus the absolute value of y2 minus y1 squared. Now here's where the cool trick is that ends up making the absolute value not matter. The absolute value turns this into a positive number. But squaring it also turns it into a positive number. So even if this here, the x2 minus x1 were negative, the squaring it would get us to the same place as if we absolute valued it first and then squared it. So it turns out we don't actually have to worry about the fact that this is absolute valued. We just need some difference. It could be positive or negative difference because we're going to end up squaring it and getting a positive value anyway. So the way this is usually written is we get rid of the absolute values and we just look at the difference between the 2 coordinates and not worry about who's bigger, so we get which one's ever positive or anything like that. So we got x2 minus x1 squared plus y2 minus y1 squared. And this is again leg length squared summed. That's a squared plus b squared equals the hypotenuse squared, which in this case is d squared. If you solve for d, you square root both sides. Again, we only want the positive square root, so we don't have to worry about a plus or minus or anything like that. We just end up with the square root of x2 minus x1 squared plus y2 minus y1 squared. And that right there is the distance formula between any 2 coordinates that you want in the xy plane. So that's it for our first video on the distance formula. I hope you'll join us next time where we'll look at an example of how to compute the distance between 2 points that's just slightly harder than the one that we did in this video. You can find that video here, or if you'd like to see a more recent general interest video on our channel, you can pick that one here. If you like this video, please give it a like and subscribe to Scholar Sauce, and we'll see you next time.